Right. Let me just introduce myself before just going to the journey. This is Kishore. I'm the Cloud Certified Hadoop Developer and Big Data Certified Analyst. This is just a brief introduction of mine. Let me just start the journey of Big Data. Before rushing into the topic, I like to just start this to the basic layman discussion. Here, in this presentation, first of all, I'll explain you what are the disadvantages of what are the problems with our storage, processing and network. And after that, how Hadoop overcome these drawbacks. So we'll explain you and we'll explain you about Hadoop. Okay, these are the 3 steps. So first step, we will go and we will discuss what are the problems with current storage, processing, network methodologies. Okay, cool. Before rushing into the topic, I like to just start this to the basic layman discussion. So consider you have a bank account which is open somewhere around 2000. After 15 years, you approach the bank and you ask them for past 3 months bank statements, which you will get hardly a couple of minutes. Consider the very next day, you approach the same bank and you ask them for past 10-year bank statements, which you can't expect the same span as you got your 3 months bank statements, because all your data will be moved to the backend, from which they will start generating some reports. It is very much crucial for organization development. In this process, storing your data, processing your data, it is very difficult and it's taking time. Let us just discuss what are all those drawbacks and why we need an alternative, why that alternative should be Hadoop. Let me just talk about data storage and processing literature survey. We know the data is too precious. We classified the data as people's data and machines data. When I talk about people's data, we the people usually generated some data from the social networking sites like e-commerce, online shopping, online reservation systems, banking sectors. We usually generate some data from the social networking sites. And we usually generating some data. We the people generally uploading images, videos, likes, comments, shares, tweets, whatnot, everything. All the stuff we generating the data. And machines also generated data like RFID readers, sensors, GPS tracers, satellite communication system, log files, mobile phones, whatnot, everything. These are all comes under the machines data. Where the challenges initially for the organizations, Google, Yahoo, Amazon, Facebook, Twitter, these are all guys who usually with the large magnitude of data. But now this is the problem to almost 90% of the organizations. They are just suffering from large magnitude of data. They don't know how to handle that. Not only simple magnitude, there are other several factors with your data. At last, I passed a bold statement stating that existing methodologies were becoming inadequate to process such large data sets. Let me just share why exactly passed this statement, why exactly I shared it. Let me just start the journey, data storage perspective. When I talk about the data storage, the first and foremost word that will strike away your mind is nothing but RDBMS. which has been ruling the industry from past 2.5 decades. Now we have some drawbacks with RDBMS. Some of them are like, number one, there is a storage saturation limit. There is a storage saturation limit where RDBMS can't hold or perform well with a large magnitude of data. We can't store terabytes of data. And schema on write. Whenever you want to upload the data in RDBMS, initially you need to define the schema. And if you get any new field other than you defined, you can't store that obviously. So you need to know what sort of data you will get in future. If you get anything other than that, you can't store it. So that is one of the drawbacks. Number two, there is no support for unstructured data, which is the most sounding stuff. Unstructured data. See, the data in which you can't design any schema comes under the unstructured data, where XML files, HTML files, log files, images, mobile phones, audios, videos, these are all comes under the unstructured data, where your RDBMS fails at this perspective. This is just regarding the data storage in RDBMS. But when we talk about the physical storage of disks, we usually purchase a SAN storage. We usually purchase SAN storage, in which we have been storing the data FC disks, fiber channel disks. In the latest enhancements are SSDs. See, basically at the beginning, people are they are storing their data sets in DAS, direct attached storage. Later they implemented NAS, network attached storage, and later currently people are using SAN, storage area networks. Here people are using SSDs, solid state disks. They are using SSDs, solid state disks. Okay. Here the word SAN, it is too expensive because we use as switches in the SAN. It is expensive. And fiber channel cables for expansion. Not only storing your data, usually you need to provide the redundancy. Redundancy means backup for your data. For that we need to use RAID levels, RAID levels, which are expensive. So finally, on an average, you can't store unstructured data. Number two, it is too expensive. So these two are the most sounding drawbacks. Number one, what are the drawbacks? You can't store unstructured data. Number two, if you want to store, you need high-end hardware. The hardware is expensive. Okay. Let me just talk about data processing challenges. When I talk about the data processing, obviously after storing the data in RDBMS environment, usually you need to transfer the data, you need to just transfer the data from storage area to processing area. Storage area to processing area, where you are using Teradata, and it is these type of technologies. Let me just share here. See, when we talk about Teradata is very good approach to process your data and to store large magnitude of data. But Teradata, it has drawback. Though Teradata can process the data in parallel way, the block size of the Teradata is only 16 KB, which is very less. And above all, it will not work with normal hardware. They will require high-end hardware like blade servers and Spark processors to work on. Here, I need to talk about your RAM. It's also become a high-end hardware. The world's largest RAM, it is 128 GB. The data storage, we already discussed, it is not support for unstructured data and it is too expensive. The same expensive comes into the picture in the data processing scenario as well. Because we need high-end hardware, it is too expensive. And it can't support unstructured data. Let me just talk about network constraints. Because the word network itself indicates this several drawbacks. And currently we are using FC cables, fiber channel cables for transferring your data, which we could acquire the transfer rate. It is 16 GB per second at most. I think you know 16 GB per second transfer rate is not a simple transfer rate. It is too huge. Though your network could able to transfer 16 GB per second at largest speed, but your disk can't read that much faster. At this perspective, I need to talk about a simple word is called disk seek time, disk IO. Though your network could able to transfer the data at this most 16 GB per second, but the disk speed hardly 250 to 400 Mbps. So obviously there will be a bottleneck problem. And we usually use Linux or Unix flavor for storing the data. You know, we have so many Linux operating systems are there. We have so many Linux operating systems are there. Ubuntu, Sun Solaris, SUSE Linux, CentOS, Red Hat. These are all Linux operating systems. These are all Linux operating systems. Here, let us consider, take any one of the Linux operating system. The block size of the file system, it is 8 KB. Linux operating system file block size is 8 KB. Let us consider you have 64 MB data. You want to store the 64 MB data into your Linux operating system. So internally it will maintain 8000 blocks. 8000 blocks. When in order to retrieve same 64 MB data, your disk head want to rotate 8000 times from one block to another block. The time taken by a disk head move from one block to another block in order to retrieving the data back is nothing but disk seek time, disk IO. Number one, that is the drawback. Number two, you know, previously we already discussed the disk speed. Simply the transfer rate it is too huge when compared to disk speed, so obviously bottleneck issue. The transfer rate it is too huge when compared to disk speed, obviously bottleneck issue. The transfer rate is too huge when compared to this disk speed, receiving speed, so obviously you got bottleneck issue. So in network scenario we have two drawbacks. This is a diagrammatic representation what we discussed till now. See, I have unstructured data, number one. If I want to store this unstructured data, if I want to store and process this unstructured data, I need high-end hardware. Number 2. So here hardware expensive. Number 3. The transfer rate it is to use when compared to disk speed. So obviously you got bottleneck issue. Number 4. The block size it is too small. So that is the reason you are getting disk IO. Disk IO. So these are the 4 drawbacks we have. Right. So we need an alternative. That alternative should support unstructured data. We need an alternative. That alternative should support cheap commodity hardware, not like high-end hardware. We need an alternative. That alternative should overcome bottleneck issue. We need an alternative. That alternative should overcome disk seed time. This kind of simply. So that is one and only Hadoop. Now we will discuss Hadoop, and before just going to Hadoop, just 2 steps, I'll explain you the important general information. The main reason behind this, why I have much focusing on data much here is, I think you heard about IDC, International Data Corporation. The work of IDC, it analyzes entire world's digital data. It analyzes entire world digital data. Basically, it's not very easy to analyze the entire world's digital data. But IDC work is International Data Corporation. IDC work is analyzing digital data. According to IDC, in 2006, the world's data is in 0.18 zettabytes. In 2011, the world's data is in 1.8 zettabytes. If you observe that, in the span of 5 years, the data increases 10 times. 10 times is not a simple figure, right? 10 times is not a simple figure, right? It is 2 years. See, zettabytes, I had given the magnitude. 1024 gigabits equals to 1 terabyte. 1024 terabyte equals to 1 petabyte. 1024 petabyte equals to 1 exabyte. 1024 exabyte equals to 1 zettabyte. 1024 zettabyte equals to 1 yottabyte. If you observe that here, in the span of 2020, the world's data reaches to 40 zettabytes. Where this data comes from? What are the sources? You know, every day millions of apps are running. Millions of the people, they have Facebook account, Twitter, Google, Yahoo, whatnot. Each and every electronic device generates some data. Each and every electronic device generates some data. So you need a tool for good storage and for processing. 80% of the data, it is completely unstructured data. We classify the data as 3 types: structured, unstructured, semi-structured. See, when we talk about structured data, best example, employee information. You can design particular schema on it. Simply you can design a table, create a table, table name, employee, ID, names, experience. So like that you can design particular schema. If you are able to design schema on that data is structured data. If you are unable to, it's completely reverse. If you are unable to create a structure on top of that data, that is unstructured data. Like videos, audios. If you are creating 50% of structure and 50% of unstructured, that is nothing but semi-structured data. Best example, web server logs. So these three are the types of data. Any data in the world, whatever the data, whether it is health domain data, e-commerce data, enterprise data, telecom domain, whatever the domain, structure, unstructured, semi-structured, total three types are there. Based on this, you can perform. Now we will discuss big data. Big data. Any data having several characteristics could be spelled as a big data. Let us talk about what are all those drawbacks. What are the characteristics of big data? Right. See. Let us consider you have the data. So that data should maintain the size. The data size should maintain greater than terabytes. You have the data. This data maintains some variety. That means whether it is structured, unstructured or semi-structured. Any one of the variety. The data, it is maintaining some velocity. Velocity is nothing but the transfer rate, the rate at which you transfer your data. That is simply called velocity. If your data maintain these three characteristics, simply you can call big data. Any data having several characteristics could be spelled as a big data. Volume, velocity, variety. Volume is nothing but size. It should be more than terabytes. If it is less than terabytes, it's not a big data, it's too small data. You can handle with your existing storage and processing methodologies. And variety, that is nothing but transfer rate. Structure, unstructured, semi-structured. Velocity is nothing but transfer rate. Okay. Now we need an alternative to handle this big data, that is only Hadoop. Hadoop is not any operating system, it's not any desktop application, it's not any web application. Hadoop is a framework. In Hadoop we have two core components, one is for storage, another one is for processing. When we talk about storage, we have Hadoop distributed file system component, and for processing we have MapReduce. HDFS, Hadoop distributed file system. This is the responsible component for storing your data. The default Hadoop distributed file system block size, it is 64 MB. The default block size, it is 64 MB. HDFS is the responsible service to store your data. MapReduce. This is a mechanism to process your data. It will process your data in massive parallel manner, not in a simple parallel manner. It will process your data in massive parallel manner. Right? Here, these two are the major core components. I think you heard about Hadoop. Those are the tools, supporting tools. These two are core components inside the Hadoop. Okay. And Hadoop can make data storage and processing at single hub, means single place. And it's a fastest processing. It's not my declaration, it's IBM declaration. They processed 1 TB unstructured data on 180 node cluster. Node is nothing but computer, cluster is nothing but group of computers. So 180 node cluster, it consumed 3 minutes 43 seconds. Same 1 TB unstructured data, they are processed with the latest enhancement of Hadoop, that is YARN architecture. It consumed 1 minute 14 seconds. See how Hadoop processes your data, and it is completely works on cheap commodity hardware, not with high-end hardware. This is the internal architecture. See, here I have unstructured data. Let us consider it's a 10 terabyte unstructured data. Whatever the data you have, the default block size of Hadoop, it is 64 MB. Even you can configure 1 MB, 2 MB, 128 MB, 256 MB, 512 MB, your wish. You can configure, but default framework comes with a 64 MB. Here, whatever the data you have is completed internally, split it as blocks and scattered across the cluster like this. So HDFS is the responsible service to split your data and scatter it across the cluster like this. Your data, it will store in HDFS. Now, as per your requirement, you want to design a simple program that is nothing but MapReduce. You can design this MapReduce with any one of the languages like Python, Perl, Ruby, any one of the language. Just design and submit this code to all computers. Here, every computer, it will process your data in parallel manner by using MapReduce mechanism. Okay. So here in existing methodologies we have 4 drawbacks. What are they? Please remind. Number 1, unstructured, it can't support unstructured data. Number 2, if you want to store, hardware is expensive. Number 3, bottleneck issue. Number 4, disk seek time. Number 1, it can't support unstructured data, but here Hadoop it will support. Number 2, if you want to store, the hardware is expensive, but here cheap commodity hardware like our laptops, 8 GB, 1 terabyte hardware like this. Number 3, the block size is too small in our existing methodologies, but here as per your requirement you can change in MBs, not in KBs. MBs is not a simple size. Number 4, you have a bottleneck issue there, but here you want. Why? Because you are moving few KBs or MBs of code over the network, not your terabytes, gigabits of data over the network. So obviously you got a bottleneck issue. So all these 4 drawbacks overcome by here, by Hadoop. Hadoop, it is very easy to move computation rather than moving data, and it is massive parallel processing for ease. Hadoop is completely works on cheap commodity hardware. You don't need to purchase high-end hardware. This is the diagrammatic representation of what we discussed till now. Hive, Pig, you heard about C. We know we just discussed HDFS for storing the data, MapReduce for processing the data. Yarn is latest enhancement of MapReduce. If you are familiar with coding background, you can just go and design with MapReduce and you can process your data with MapReduce. I am not familiar with coding background. I have SQL background, SQL background. Now I want to process Hadoop, Hadoop data in Hadoop. So what I will do, I have one more tool, that is Hive. I don't know coding background, I don't know SQL background, so I have a scripting background. You can go with the Pig. Like this, we have different tools are there. Zookeeper is the server coordinator, Flume, log collector, Scoop, data exchange, Woozy is a workflow, Mahout is a machine learning, R connectors for statistics, HBase is a NoSQL database. So these are the tools we need. Okay. Now, not only these tools, you have Several tools are there. You heard about Spark, Kafka, Impala. So these are all big data tools only. Okay. In our training we will go with all these tools. I'll show you everything if you are okay with this. And these are the distributions. These are the distributions. Here you heard about Apache Hadoop, I think. Apache Hadoop is completely open source. You can download and configure in your machine and your organization. No one questions you why you are configuring my distribution like that. No need to purchase license agreements, no terms and conditions, no privacy policies, nothing else. If you got any issue, no one is there for supporting. Based on this open source, Cloudera is one of the organization. This was just created its own environment with a Hadoop distribution. So this is completely commercial. You want to purchase license agreements and everything. If you got any issue, they will support you. Microsoft Hadoop is called HD Insights, Amazon Hadoop EMR, IBM Big Insights, Hortonworks is one of the Hadoop distribution, EMC Square, Greenplum, HP, Vertica. We have so many distributions are there. In all these distributions, these are the familiar distributions. Hortonworks, Cloudera, Hadoop, Apache Hadoop, Amazon. Okay, these are the familiar distributions. See, these are organizations, they are using Hadoop. Okay, this is just brief introduction about Hadoop. If you have any queries, you can fire me with your queries. So, is it clear?
Yeah, it's clear.
Okay, any more queries? Any more queries? So clear, right? Yeah.
What distribution are we gonna use?
Sorry?
The distribution. Which one are we gonna training? We are using Apache, or we gonna use Cloudera or Amazon? What are we gonna use?
Okay. See, what I will do, I'll explain you Hadoop, Cloudera and Hortonworks. These three I will show you. I will configure in your machine. There is no purchase license agreements, nothing else. You don't need to purchase anything. Everything freeware. Here we have trial versions. We can use those trial versions. You can play with that.
Amazon is a paid version?
Sorry?
The Amazon Web Services, AWS.
Amazon Web Services, Elastic MapReduce, that is called EMR. So this Elastic MapReduce, same like Hadoop, Apache Hadoop. Same as it is, same like that. But here some supporting team is there, but here they are not. That's it. That is the variation.
So instead of Hortonworks, I have seen the requirements asking for Amazon Web Services, but since it is Apache is similar to AWS, then it is fine.
Actually, AWS is different, EMR is different. AWS, Amazon Web Services, means is a cloud operation.
Yeah.
That is not Hadoop completely. It's a cloud operation. EMR, Amazon EMR. You heard about EMR distribution. If you heard EMR, that is Hadoop distribution. That is Elastic MapReduce. Same like our Hadoop 2 version.
More popular is Cloudera and Apache. I think
Cloudera and Apache I will configure in variation. You are asking me variation?
Not asking me. That is what popular is. That's what the company is asking.
Obviously, see, first Apache is the simply father of all the distributions.
Yeah.
Based on these distributions, based on Apache Hadoop open source, rest of the distributions they designed. So here, right now in current market, Hortonworks and Cloudera, these two are in competition.
What do I need in the environments to start this, practice and all?
Simple.
Say,
If you
do
have
I need
8
Oracle
GB,
or SQL?
yeah, if you have 8 GB,
Mhm.
just Cloudera Hortonworks, you can run it. If not, I will show it in my machine. If you have 4 GB or 2 GB at least of RAM, you can configure Apache in your machine.
Uh-huh.
And you have Windows or Mac?
This is Windows.
Perfect. So VMware workstation I will configure in your machine. Inside the VMware workstation, I will, just a minute,
We
I
can
think,
create a VMware in my laptop. It is 4 GB. It is not 8 GB. So
no issues.
even in the 4 GB we can get the VM and then get the Cloudera also, right?
You can get Cloudera, but Cloudera need 8 GB at least. That's why.
Okay, okay.
Why? Because it's so many packages are there and heavy weight it is. That is the reason.
Okay. So
It,
once if this Apache Hadoop, this is the parent one. If I'm good with Apache Hadoop, the Cloudera is just a different distribution. So all the other logics are similar.
everything, see, whatever the code you designed Apache without any modifications, you can distribution on any other distribution. The
Mhm.
variation is, major variation is just a user interface. Hortonworks user interface is different, Cloudera user interface is different. Apache there is no user interface actually. It's
Okay.
open source. Through terminal you want to do.
Okay.
And no problem, Cloudera Hortonworks I will show it in my machine. No issue. It's a 12 GB machine, my
Mhm.
machine. So I will show you. You can practice in my machine. I will give you credentials.
And how long does this session? I mean, the training session will finish in?
It will take 35 working hours.
Okay.
35 working hours.
Okay.
And I'll give you resume preparation and interview questions and material and everything. Books, 43 books I have. So if
Okay.
you have time, you can read 43 books.
Yeah. So that will prepare me for interview also.
Yeah, interview questions also I will give you, not like simple questions. In-depth questions I will give you. If you focus on those in-depth, simple questions you can easily answer. If you learn simple questions, in-depth questions, it's you won't. If you focus on in-depth, obviously simple questions you can play with them.
Okay. Sounds good.
Okay,
Mhm.
okay. Any more queries? If you have any queries,
No queries. I
okay.
think I'll get back to her.
Sure, sure, sure. You can just communicate with them. If you want any course content, everything, they will give you. Okay.
Okay. Sounds good. Thank you.
Please contact with them. If you're comfortable with that, we will start. Okay. Yeah.
Okay.
Okay.
Thank you.
So yeah. Thank you.
Bye.
Bye bye.